Good. All right, I think we're starting, guys. Hey, Casey Rosini, and you're at my talk about stuff that's been done already with memory-based library loading. So thanks for coming, and after last night, apparently. So based on this track, I guess if you're expecting to break lots of stuff and do lots of stuff with the stuff that's in this talk, and the stuff that's made up of other people's stuff that's now our stuff, which is the stuff of other people's stuff is made from, to do stuff that we made them eat. Yeah. I don't know. But to be honest, this is going to be mostly about other people's work and how the memory-based techniques have been around for a while and continue to be used. And I tried to make a really conscious effort to be open about that in this presentation and other people's work. And that said, I really wasn't sure how to theme my presentation. You go out to websites and whatnot and different talks, and they always have some sort of theme or gimmick. I mean, it's cool and all, but it makes it relatable for sure. But in the spirit of DerbyCon, I didn't want to do anything too gimmicky. So no cyber in the hacking sense. There's so many different references out there with like coded characters and whatnot, binary numbers and polarizations and colors and stuff. You can just search Google Books and you get an idea of what's out there on the cybering. Cyber Knife is one of those. Psycho-cybernetic and post-cyberpunk. And some good company names in there probably as well. So no cyber. And not to be outdone by ninjas, or no battle references in general. So no ninjas, knights, wizard, and maybe if you've seen this movie, warriors, come out and play! Okay. No magic things or secret art forms, especially no magic quadrants, because we all know those are useful. No mythology, even though Clash of the Titans is a classic and just something about the new one's missing. Finally, no self-centering. Plus, you all have friends here, congoers, to get us out of that trap. And if you have kids or family, they get you out of that too. So hopefully I won't get in my own way, sound too contrived, or sound like I'm reading off the slides too much. But today, like I said, interest is in other people's work for the simple sake that other people did it already. And hopefully I can be like an arrow or something else that points to something that isn't an arrow, like a cat. Womp womp. Never said any cats, so it's a talk, right? You're supposed to do cats, aren't you? So is this con worthy? I asked myself this question because I didn't want to come off sounding like I want to take credit for everyone's work that's out there, and it's kind of a daunting task, and it's not really my decision on whether or not it's worthy. So the non-bullet point answer is a lot of positive and negative encouragement from friends. It's cliche, I know, but without them, I kind of be stuck in my own loop, sitting at my desk going, oh, well, someone did that already. So rather than do that somewhere else, I decided to do it here on a much larger and more humbling scale, and on YouTube apparently as well, so great. So I hope to be a herald in any capacity, even if that means admitting that I'm not like the foremost expert on all this stuff. And I couldn't find everything out there or even recognize everything, or everyone for that matter. So sorry in advance to all those people out there. Yes, that's my current LinkedIn title, Base 64 Cryptographer, and I do what you would think an AppSec person would do in a developer-type enterprise environment. Reviewing code that you're not familiar with, larger scale compliance assessments or pen tests, sometimes doing actual pen tests, etc. I've done Patch Tuesday webinars in the past, which were usually preceded by a sleepless night, but I've never done a con talk. And all that said, another cliche thing here, but I've encountered a lot of amazing people in this industry and outside of the industry as well, good and bad, and they just had a lasting impression on me. So I just want to kind of extend a general thanks to them. But anyway, on to the talk. So this concept is not necessarily new. And when I was out there researching it, I thought that I found some amazing new thing, but TLDR, it's not really all that new. You can just Google search and you'll find a ton of different sites and resources. And if I wish I were joking, but it's true. If I posted it somewhere, I'd like to think that someone would be like, oh yeah, well someone did that like 10 years ago or whatever, but it's still a possibility that they'll do that with my talk, but you don't see it out there as much as you think. And it's still kind of a little obscure. I mean, you see it, but you don't really see it. And you see it mentioned, but you don't see it mentioned like, you just see it like a bullet point thing here or there. It's kind of like when Microsoft started doing their advisories and they started giving credit to researchers in like size 12 font for these dudes that found these Win32k vulnerabilities. And then I don't even think they do that anymore. I think they actually just reference you to another page, which even adds insult to injury. So it's that kind of stuff that kind of motivate me to want to give credit and recognition. And I think we can move past that kind of stuff in this industry. So, speaking of that point, the talk's going to be mostly focused on Windows, with an emphasis on one particular project that I didn't create, and how the technique is going to, how it's used in the real world by real people and real things. And I'm going to try and take a big step out there and compare and contrast it to some other stuff that's already out there, which I also didn't create. And it's going to involve some background, history, and but it's nevertheless noteworthy. And it's not my intent to drown you with a ton of information. It's a long talk, but there is a lot of information. I just want to give you a heads up. I want to just give you a broad perspective of what's out there. And toward the end, I'm going to come back to the topic technique, as I call it, and give you some real world stuff. Slight disclaimer, I'm not releasing frameworks, but I'm going to give you some people that have frameworks already. I'm going to give you maybe an example, but I'm not going to guarantee it's going to be a fully undetectable evasion. And I'm not going to disclose anything that's been not done already. So by the end, you should at least have a general concept of how to do all this and kind of take it and run with it and maybe do that on your own, which would be awesome. And see you guys up here doing it. So let's get our hands dirty. So we probably know libraries are executable files, and they follow the PE format. This includes exe and DLL, but there's others that adhere to the format, like OCX, but we're not going to talk about those. Primary takeaway is that exe and DLL are similar, and they contain code and resources and data, and we don't necessarily need all of them to have a valid PE. This will be relevant more later when you get your when you get into it, but PE files are formatted and handled by the Windows loader, and it's not, the Windows loader isn't explicitly required to load your libraries, as you'll see, but generally speaking, you'll need running exe to actually load your library, and that might be something like even like the built-in run DLL32, which if you even search like the registry, you'll come to find that there's handlers out there that are spawning it. Like I think on like Windows 7 or XP, it's like the image viewer is actually like a DLL that's run. So that kind of stuff. So DLLs, you might be familiar with them, maybe even outside generating them from exploit frameworks, but you should at least know that they're not hard to make, and that the standard spec-conforming DLLs are going to be very useful with memory-based techniques. And it's kind of interesting if you start applying that to machine learning and how that stuff starts, how it learns based on the file format specifications. But anyway, topic for probably another talk. Easiest way to describe DLLs is that they're a module of things for another module, with a module being another application or DLL. And the module's things are functions and data, and they can be internally used or exported for external use. So we're going to focus on runtime dynamic linking, and that more generally consists of the load library API, which is built into Windows. So another point worth noting is entry points and DLLs are optional. So in essence, this just means that you don't need to have code that does things when your library is loaded. It just could be straight up use of your library. Next is the loader search order, which you might more know it from its infamous name as DLL hijacking or sideloading. But in short, that just deals with loading relative paths or just security settings. But this was all the rage, like, it seems like yesterday, but it was more like 10 years ago. But it's still relevant, and it is highly dependent on the application. And it basically involves what we just discussed, functions, data, entry points. So let's touch on the minimal PE file format, just how they're loaded from some visuals from Angie Albertini's Corkamai project. So basic bare minimum exe, and it just returns a exit status code. And what I think it really demonstrates is just how versatile and easy the PE format can be. It has all the headers in code, and it doesn't necessarily need to have everything defined in a PE. And there's other research out there on that from Alexander Sotorov, for example, Tiny PE. He has some research called Creating the Smallest Possible PE Executable, where he goes on to discuss how he just created this super small PE file to download a payload and execute it. And there's a lot of context there too, so that's worth checking out as well. And this, just to note, the small form factor aspect might actually be more interest for payload creation later on. So that way, when you're generating these payloads or making them on your own, hopefully, you don't necessarily need to have the whole full-out blown headers and whatnot. You can kind of really slim it down. But back to the PE format. PE 101 graphic from Corkamai. So I'm not going to try and act like this isn't the 1000th time I have to reference this, or even like the millionth, but it does provide a really clear picture on PE files with a standard exe, and you can see it's broken out a lot more complex. But just a note is on the top right, I know you can't, I wish you could see it better, but if you go to the site, you'll be able to get it. There's little numbers on the top right that correspond to the loading process on the bottom, which is what we're going to be talking about in general. So first parse the headers, then the sections table. This is in the PE format. After those are parsed, the file is mapped into memory based on the specs defined within the header. Next, the imports are all handled and loaded until the code is finally called at the entry point. That's it in a nutshell. So kind of fast. You might have taken some pictures, but you can go over to Angie Albertini's Corkamai page, project on GitHub, where you'll find all the visuals. And there's also POCs there, a lot of assembly code. And it's literally just in a POCs folder, so just go there. And it's not only about PEs, there's binary files there like PDF, I think, and maybe even some image files. So if you want to use it, and I encourage you to support it at the Patreon site. So thank you, Andy. I'm glad this isn't a talk on PE. So there's a lot of resources out there, seemingly random ones like I've tried to show. And they're not always the standard search query, so maybe just use your imagination. But the main takeaway, EXEs and DLs, similar, and so is their loading process. You don't need to know all the inner workings per se, but you might want to know in case stuff starts going haywire or you want to hack on it. You can use payloads all day long. You can generate them and whatnot. But if you don't have some tool to generate it and fix it for you, I mean, how are you going to be fully undetectable, right? So in general, documentation is a good start. If you're not a dev, API documents and source aren't going to really work for you. So I just recommend that you just keep looking if you're interested. You might find stuff that sounds too complicated, and even if you need to find another source that seems outdated, it might be worth checking out. Which brings me to Matt Petrick's Peering Inside the PE, which is a tour of the Windows 32 portable executable file format, and that's from none other than 1994. You've probably seen it, heard of it, seen it referenced somewhere. These days, Microsoft puts all their stuff online on their open spec format. It's all this super formal whatever and whatnot. And that's great and all, but I kind of like the commentary of Matt's article. And it also gives you 16-bit application stuff in case you need to attack the NT-VDM stuff, if people are still brave enough to even run that. So if you can't read it, it's available via CompuServe 71774,362. So main talking points here, memory-based library loading. Particularly, I'm going to talk about two major projects with an emphasis on the latter. The first is Darth Tun's Blackbone. Blackbone is this comprehensive Windows memory hacking library. You might have heard of it. It includes a ton of features specifically geared for hacking all the memory things. It also provides the means for mapping PEs in the memory, this library-based loading. And if I'm not mistaken, it does remote processes as well. But according to the MIT license, it's been around since around 2015. But if you dig a little deeper, you see it was called Dark mmap, and that was around 2013. But there's a ton of features in this thing. Seriously, it's a topic for another talk. Hopefully, Dark Ton will give it. But in any case, they're worth mentioning. So, huge list. You can take your pick. This is literally a screenshot from the GitHub. Once you go there, you'll see. But there's even a driver there for extra hacking. So, Darth Ton, cheers. Thank you. So the actual topic technique of the talk, it's been around for over a decade, and in my opinion, it most easily employs the technique, and it's just pretty simple to use. Documentation is easy to follow. So without further ado, Memory Module by Joachim Bauch. I hope I said his name right, because I emailed him like a month ago just to make sure that I would say his name right. So I'm sorry, Joachim, if I messed it up. But he's been working on this project since around 2004. Can you believe it? As far as I can tell, it appears to be the first publicly available library that was doing this sort of stuff. You can check out the archive.org if you're interested too. There's other people out there that have conjecture on whether or not they did it and whatnot. I'm not going to get into that. I just kind of tried to reputable sources, which I guess archive.org is one, right? But 2004, and it's specifically designed to load DLLs from memory, from a DLL into memory. And from my time, like I said, it's been really simple to use, and it gets the job done really well. Pretty fancy, as GitHub implies, and that's the reason why I'm going to talk about it. No, I'm just kidding. So lastly, I asked Joachim, is there anything that you want to share with anyone that's not on your main page, not on your GitHub? And he said, my first use case for memory module, I'm sorry I'm reading this, but to protect some proprietary C Python modules, which are DLL files, I had a loader, which was a Python module, and initialized with license files and decrypted and loaded the actual modules from memory using memory module. That's how the project started, and it was interesting to find out how loading libraries work internally on Windows. I liked the code and hoped others might too, so I decided to open source it, which is pretty awesome. And for that, I want to say thanks, Joachim. If you still need more reasons, it's been around for over a decade. It predates all this security research that we've come to know and love over the past few years. Secondly, it's not necessarily a security research project, which was super refreshing to me because this kind of stuff can get quite verbose, like this talk. Lastly, code and documentation are pretty clean and easy to follow. There's two primary code files, memorymodule.c and memorymodule.h, and you don't have to be a hardcore C programmer or C++ programmer to read or build it, which was more appealing to me, because I'm none of those. So let's talk about his memory module, and hopefully not get too distracted by shiny things. So it basically emulates the Windows PE loader, like these functions here, load library EX, get proc address, etc., etc. And as I said, it's fairly easy to use. All it really ends up adding is memory to the beginning of it. So load library, memory load library, closely resemble the API there. So how's it like the Windows PE loader? He documents it fairly well and pretty extensively, and it pretty much matches what you would find on these earlier slides that I was talking about. So you might not read the docs, even though they're pretty easy. So let's hear the docs like an audio book. I guess that counts as reading, right? But seriously, don't leave. I'm going to get to the real world cases afterwards. I just want to kind of emphasize how easy it is to map it to the code and just kind of give a bird's eye view of what it looks like. So let's map it, these docs here, which is just a short little portion to the memory load library EX function. And it's not going to be one-to-one, but I'm going to do it anyway, so I don't care. One, in the docs, open the given file and check the DOS and PE headers. Remember, this is in those graphics too. 2, we'll skip 2 because it seems to be done later, which is also sort of in those graphics as well. 3, parse the section headers and copy sections to their addresses, etc., etc. So basically, destination address for each section relative to the base allocated memory block is stored in the virtual address attribute of the image section header structure. Wow, I sound like the Micro Machines man, if you remember him. So, out of order number 2, try to allocate a memory block of PE header, the optional header size, dot size of image bytes at position, PE header, dot optional header, dot image base. 4, if the allocated memory block differs from the image base, various references in the code and/or data sections must be adjusted. This is note called base relocation. So of note, the result variable, which is allocated there, it's on 601. It actually stores these custom dependency loaders, which you can end up customizing, obviously. 5, required imports are loaded. 6, memory regions in different sections must be protected depending on the section's characteristics, etc., etc. Now the library is loaded completely. It must be notified by calling the entry point using the flag DLL process attached. And that's not the only flag. There's other flags. There's like DLL process, one for detaching, which basically ends up getting executed when it unloads your module. So you can see in this code, if you can see it, it's the image, the optional header for the entry point. If it's defined, it'll get executed. I also want to point out there's a DLL entry proc and there's an EXE entry proc. That's line 668 and 677. Technically, you can load an EXE just like you would a DLL, with a low library. So I just want to say you can customize it with the custom do thing functions. Basically, you just are able to customize dependency resolvers. And this just ends up getting used during the loading process. So like when you're doing imports or copying sections. If you call memory load library instead of memory load library EX, that will just use your default custom handlers defined in the library. Using it. So this little blurb here will get you started by just loading a file in the memory, loading from a file into memory with memory module. It's file-based, but you can change it however you see fit. It can be like remote or whatever idea you can dream of. Key point, you can obscure the payload too. You can be something even that's not a DLL file. Eventually then though, you can obscure it so far, but you're going to have to obscure the loader because people are going to want to detect it, right? So anyway, basic steps here. If you can't take a picture or your pictures end up turning out a little messed up, you clone it, modify it to suit your target architecture, modify his example DLL source, then just build it. Generate your payload, copy it over, maybe add a XOR if you want, and then test it. So this is the original example with a little bit of modifications, basically just stripping out test code, maybe hard coding my file name, and adding a XOR decoder because what would a POC do without a XOR? If there's bugs in it, you can, and when I put the slides out there, you'll be able to check it out a little bit better, but if there's bugs, you can just open up a memory module there. It loads the payload described, like I described in the last few slides. So the loading process, all that rigmarole, it basically does just that. But like I said, it's going to end up becoming an exercise in obscuring your loader. To avoid detection, and as I'll say ahead, there's some purported sources. I say purported, and you'll see why. In order you might want, it'll become like this exercise to reduce memory artifacts so that when people are doing memory forensics, they won't be able to find your stuff just chilling there. So anyway, you might have varying success with this. It's the example, but I mean, that's where the fun is. So if you didn't know why, this is the reason. If you haven't figured that out, sadly, those tags have always avoided regular use cases. So just to kind of wrap it all up here in a little bullet point slide is it's like the native load library, except it's memory load library and memory load library EX. There's also other functions. there's resource loading APIs, so that could also be of use, like icons or whatever else you can stuff into a PE. Payloads can be with or without files, and the files can be obfuscated. It's worth noting too that a completely like fileless approach, it could actually hypothetically reduce your delivery methods. So don't put out the file-based stuff just yet. So we'll circle back to the memory module technique soon. So let's compare and contrast to some of the other methods out there. Is it DLL injection? It's not DLL injection, but it's similar, namely just in how the library loading is performed. In contrast, DLL injections will use create remote thread and write process memory APIs to achieve its injection and then execute. They also will end up calling a load library as well. But memory module, it actually just allocates and uses its own executable memory, so it's not actually remote. So let's take a quick look at a couple of other projects that are DLL injection. One of which is one by Borja Marino, and it's called Pazuzu. It takes some cues from some other projects that are using memory-based techniques. His project is more meant to be customizable in order to define your own binary to execute on the endpoint. So if you have really tailored stuff that you want to do, his project is definitely a good one. And he has a couple different ways of achieving it: process hollowing, reflective DLL injection, or just straight up executing from disk. So thanks, Borja. Darth Tun again, he has Xenos, and as you might imagine, it has the complete features, maybe not complete, but most of the features from Blackbone. There's even injection profiles, which I thought was pretty cool. Thanks again, Darth Tun. This is the one you probably all know about, is Stephen Fewer's reflective DLL injection, and it's used by various forks out there. Projects like Pazuzu, I believe, even use it. And it's probably more well known because it's in Metasploit and Empire project as well. But his description sums it all up. It's basically a DLL that loads itself using reflective programming. So Stephen, thank you. Oh, so some more fun facts. DLL injection's been around longer than you think. I actually thought it was something out of the early 2000s, but turns out it's not. I'm not really sure why I thought that, but after following some references, I came upon this article from 1994 from Microsoft Systems Journal. Let me see. It's called "Load Your 32-bit DLL into another process's address space using injlib, injectlib" by Jeffrey Richter. Man, I miss long titles like that. So 1994, I don't even think I had a computer yet. Probably watching cartoons, and I'm still watching cartoons. But if you're interested, you can download the source. It's still on Microsoft's website, surprisingly, and none other than a WinZip self-extracting exe, because it was the 90s and we didn't know. So Jeffrey, cheers. Thank you for injectlib, and thank you for your work that you're probably doing now. That's equally as cool. So moving back to contrasting with other techniques, isn't it just process hollowing? Isn't memory modules technique just process hollowing? Well, it's not even really that similar. But just remember, memory module or this load library technique, or memory-based library technique, isn't it's loading into the same executable memory address space. So process hollowing actually will spawn a new process and replace that host process with new code. So that will occur through like create process API, spawn a new process in a suspended state, and then hollow it out and replace it with its new code, and then obviously execute. It's not the memory module technique, but it might be kind of cool to see how you could blend them together and maybe do some pretty cool evasion stuff with it. Interesting fact on that though too, which I didn't even think I could find one. But in 2007, Nick Harbour had this talk at Black Hat about stealth malware techniques, and he refers to it as Nebbit's shuttle. Interesting. It's really interesting though. Thanks, Nick. But why Nebbit's shuttle? I was like, is this like some Galaxy space trooper or whatever reference? No. If you go and follow his references, you'll find a couple posts on Google who bought Deja.com. from December 2000 and February 2000. And it has all this different source code in both the posts. One has a little bit more verbose than the other, but you end up coming upon this code, and it's for what we now refer to as process hauling from none other than Gary Nebbit. So ergo, Nebbit shuttle, even though I still am confused where the shuttle part came from. But in any case, just want to say thanks to, why isn't this working? Gary Nebbit. Thanks, and thank you for your shuttle. So wrapping this whole contrast, long-winded thing out, there's a lot of different techniques out there, and they're not all discussed in this talk. I just kind of picked a few that seem pretty similar in the loading process, or even that might be cool to look into. But memory module has its own technique, and like Blackbone, it has this process as well. And hopefully we learned a few fun facts. So let's check out the real world stuff. Plenty of people think this code is pretty interesting. Source code sites, like you'll hit code project or whatever. People on the game sites, so game hacking sites, for example. People are porting it into different languages, like Delphi, for example. Who would have thought? Legitimate software even uses it too. So if you've ever used PyDXE, it's also wrapping the functionality as well. But security people in our industry are also using it, surprise, surprise. So first is Didier Stevens. You probably know him from all of his cool malware tinkering tools, but you might not know he actually ported this in 2010 into shellcode, which is pretty awesome. And a few months later, it was featured in Hackin' 9, April 2010 edition of the magazine. So if you can attain that article, check it out. I had some trouble getting it. Apparently they used to be free, I'm not really sure. So I recommend checking out his blog, and he explains everything there. So thanks, Didier. Paul Jung's talk at hack.lu in 2014. He references memory module for bypassing sandboxes. Essentially, he has these straightforward techniques to detect the presence of virtualized environments or sandbox environments, and I'm totally summarizing here because it's super detailed. So eventually, he does reference memory module for loading a DLL in a sandbox environment. So check it out if you have a chance. Thanks, Paul. Next, Josh Pitts and Travis Morrow. This is the one I'm probably most excited to talk about because it's their genetic malware project, or more specifically Ebola. It was released last year in 2016 at Eco Party or Infiltrate. I'm not really sure which because I didn't get to go, but in their talk, which is on GitHub, they have a whole kind of list of environmental keying methods that were proposed by all these different smart people throughout all these different years, and none of them really give you a POC, at least not until now. So the framework uses a few techniques, one of which is memory modules. In short, it'll execute a payload in memory only after decrypting the payload using keys that are derived from that particular environment. So as they point out, it's really quite awesome because you can take a variety of target inputs like environment variables or net masks, and I think even they said binary, so you can target a specific version. They used BitTorrent as an example, and just target a specific binary version. So then it'll just decrypt it using all those things. It doesn't even check it; just basically brute forces all the files, and then uses it to compute the. I hope I'm getting this right. Uses it to compute the key, and then loads it in the memory with memory module. So think about this for a sec with a pen test where you have different scopes, and you don't want people releasing stuff outside of the engagement. You might have hard-coded credentials or whatnot, or even smart IT people that will take it and upload it to hybrid analysis or VirusTotal or some other virus checkmate, whatever you use. You don't want all that stuff getting out. You don't want your secret sauce getting out there either. So you can see what I mean. It's pretty powerful, and it really kind of uses this whole technique for what we would want to do. So Josh and Travis, thank you for some amazing work. So there's not only security people using it, There's not only other people out there on source code sites, there's also leaks from purported government agencies. And I say purported because if you're inquisitive or paranoid, you can't really tell who is who or what is what or who's behind my back or whatever. There's no clown behind me. So this graphic could go any different way too. But anyway, purported data leaks, and for the record, nothing classified in here or purportedly classified, and it all appears to be official use only, and this is official, so anyway, there's basically no information. So there's a lot of references, but nothing that you really want like code to read, go figure. But the information that you do find are some guidance documents, and they basically outline functionality that's similar to memory module. Like we discussed in the example code, you might need to modify the loader, for example, to account for different things. So in that spec here on the bottom right, and you'll be able to see it eventually, but they actually they talk about applying a default page permission for a module section like the native library loader API in order to prevent the allocation of a single chunk of page execute read write memory that can be found by memory forensics. So ergo, this all kind of leads in together. You can see how it's all sort of playing out with this whole landscape of memory-based stuff. So even though there's no information out there on this whatsoever, at least in the leaks, at least the malware in this can shed some light on the topic. So there's Longhorn, and Kaspersky refers to this as the series of Lamberts, these colored Lamberts. I actually think that it's called Black Lambert, but Symantec released it and they called it Longhorn. Whatever you want to call it, I'm going to call it Longhorn. What's interesting about it is when it's all broke, AV vendors, they didn't even really talk about the whole memory-based plugin technique. I mean, don't you think that would be something that would be like this key factor and detail about this malware that's super awesome and like, but no, I don't know why. But there's always someone out there who wants to know more and wants to know why. Like Arnaud Delmas. Arnaud is a French researcher, and he's a reverser who performed this pretty excellent analysis on Longhorn. So I'm going to paraphrase it, and I'm sorry for not doing it the justice it deserves, but he gives these complete list of details on the different functions, and he goes in to reverse them and even correlate them to this guidance document that's in these leaks. He gives you scripts for decrypting the strings, and he even gives you C2 behavior, and he links that to these other purported code names or whatever. So moreover, the correlation is really compelling. You can take it for what it's worth, but on the bottom right, he prefaces his analysis by saying that the in-memory execution component, or ICE, he says it's basically Joachim's memory module code. So thanks, Arnaud. Keep up the good work and hang in there, man. So yeah, tons of uses for memory module. And we're almost through them all. So there's still some that are relevant. So various forks of memory module on GitHub. Tons of them. And I wish you could see them, but if you do, when you do end up actually looking at them, there's going to be ones that just jump out. You're like, whoa. So when you go into these users repositories, you see these different forks for not just memory module, but all these other things. And when you start putting them and wombo-comboing them all together, you can see this trend of intention for this stuff. Like, it's going to be a good research project. So if any of you want to take it up, definitely check it out. And there's no doubt probably more. And it's a bit confusing too, with dates and going back and trying to attribute people with different stuff and where everything originates, and seeing there might be other malware out there that was probably doing it, possibly. I don't know. Game hacking scene, not that I know the scenes, seems pretty active. They would be a good resource for sure. And there's other people out there that I just want to recognize in general, because they're out there and you know that they're doing something with it, and we know you're out there, so keep on it, guys, and cheers to you. Hopefully you're doing something good with it. So wrapping up the talk, how can you do stuff with memory module or just the technique in general? Fork and build a source. Don't be afraid of it. Hopefully I gave you enough kind of insight to get into it and not be afraid about getting your hands dirty with it. And hopefully we can make this a little less obscure to the community. Look at Joachim's source examples. Like I tried to demonstrate, it's super simple to use, super simple to modify. Look at legit cases like PyDX even. Pitts and Morrow's Ebola framework, all the other research repositories, maybe even try it with existing frameworks like Cobalt Strike or their artifact kit. I know those guys are here, so maybe they'll consider doing something like that, or you guys can do it as well. Experiment with the different delivery methods. And I say this because you think about something like, if you decide to contribute to something like Ebola, you could think about what you could do with that. You can make a nice staged delivery system with that and kind of just send stuff out, and it would look totally legit and legit traffic. And all you would need to do is send out basic environment variables that look totally legit and just load it up like straight up image. Oh yeah, cool. I'm running this browser, or maybe just even base64 encrypted. I don't care. More use cases, like Joachim says, he originally intended it to be code protection. So obvious use case would be maybe code protection. I don't know why there's tons of good stuff out there, but you could probably even apply those other techniques now to obscuring your payloader. So just honestly use your imagination, be the next cool kid, pick something you're interested in, and go from there. Look up some of the techniques out there, the frameworks, see how everyone else is doing it. Like Pitts and Morrow's framework, as I was just saying, and maybe even like stuff like Metasploit. I actually tried to go and look at Metasploit and Meterpreter, and it might be beneficial to just have a straight up plain DLL that doesn't have reflective DLL injection. So if you feel like taking up that task, maybe port Meterpreter into just a standalone plain old DLL. Obvious use case, like we said, establish evasion. I personally tinkered with Ebola when I was testing stuff. Had a lot of great success, and I wanted to kind of push it further and just see how simple it could actually be to test these next generation digital thingies and even just traditional based digital thingies. So I just got the example and built it. Wrapping this all up, eventually someone's going to want to look at this stuff, and that's basically computational expensiveness. So hardware versus machine learning models. There's going to be a degree of, in order to even scan this stuff in memory, there's going to have to be some sort of computing power to even handle it. So that's something to consider. Even maybe on the bottom there as well, that kind of ties in with detection. But also that could be threat hunting. And I believe there's actually another talk today about that stuff, which should be a cool one to check out. Other people's stuff, sites, forks, researchers, and maybe even just alternative implementations like I touched on. Standard PE could possibly help you evade machine learning, just using a straight up plain old DLL for your payload if you don't want to obscure it. So the whole talk basically emulating PE loader for memory-based evasions, tons of projects around like Joachim's, and just consider contributing and tinkering with this stuff. Honestly, we got to make it a little less obscure. And lastly, tons of smart people, talented people out there, named or not. I'm just really honored to stand up here and do my first talk and get the information out there. So thanks, guys. That's it. So I don't know if you have any questions. I actually thought I was going to run. I was running fast on this, so if you guys have any questions, I can try and answer them best I can. I don't know. Good. So I'll probably put all this